You are given nums and queries. Each query is a closed interval L through R. When you use a query, every covered index may drop by 0 or 1, chosen independently. You want to delete as many queries as possible while the remaining ones, in order, can still zero the array. If you cannot zero nums even with all queries, return -1. First example, nums 2, 0, 2. 3 queries, 0 through 2 twice, then just index 1. Apply the first wide query, subtract 1 at index 0 and 1 at index 2, not at the middle. That yields 1, 0, 1. The second wide query does the same, reaching all zeros. The third query only touches the middle, which is already 0, so it is unused. You can remove that one query, 1 is the maximum you can delete, so the answer is 1. Second example, 4 ones and 4 overlapping interval queries. 2 of those queries are redundant while still zeroing the array, so the answer is 2. The question is which queries we actually need, and which we can throw away. As we sweep left to right, we hire intervals that reach the farthest right, so each hire blankets as much of the array as possible. Anything we never hire goes straight to removals. We sort the queries by start index, smaller first, stable ties. That gives a timeline, we only meet each interval when the sweep reaches its left end. The score we want is how many queries we never had to hire. Think of every never hired query as points toward that removal count. Sweep left to right. When the scan line reaches an interval start, it joins the waiting room, a max heap by right endpoint so the longest reach sits on top. Here the column still needs work and nothing active covers it yet. We pluck the waiting query with the farthest right end, because that buys the most future coverage. At this column, 3 queries all open at once. Each one joins waiting because the algorithm only hires from intervals that have already started. They stack in a max heap by right end so the longest reach stays on top for the next hire. At the next index the hire still reaches us, so we do not dip into waiting again. Same hire, longer reach, fewer new hires later. When the sweep finishes, intervals still sitting in waiting were never hired. That count is what you can delete, here 2 remain in the heap, matching answer 2. The trash is just a mnemonic for that removal score, not where the chips literally go. Detailed solution on the same hard example, nums is 4 ones with 4 interval queries. We want the largest number of queries we can delete while the remaining queries, in order, can still reduce every cell to 0. Sort the queries by left endpoint L, smaller L first. When 2 queries share the same L, keep their relative order from the original list, so the sort is stable. Sweep each index I in advance queue along the sorted queries. At index 0, we focus on column 0. The next sorted query opens here, interval 0, 2. Push it onto the waiting max heap. Nothing is active yet, so we hire right away, pop from waiting, then place that query on active. Set hired to 1. At index 1, 3 queries start at this column. Push each onto the waiting heap in order, the right endpoints go 3, then 2. We do not hire yet because the active query still covers this index. At index 2, no new query opens, so we only advance the sweep, the heaps stay unchanged. At index 3, the smallest active R is less than 3, so that query expires, pop it from active. We still need coverage here, so pop from waiting onto active, then set hired to 2. There are n equals 4 indices and hired equals 2 queries that consume our deletion budget. So 4 minus 2 equals 2, you can remove at most 2 queries, that is the answer. Second example, nums is 1 then 1, with a single query 0 through 0. It can subtract once at index 0, but it never touches index 1, so the second one cannot be cleared. Only one query, so sorting by left endpoint is already done. Again we sweep indices with the waiting in active heaps. At index 0 the value is 1, so we need one decrement here. The query opens, push interval 0 0 onto the waiting heap and advance queue. We hire it, pop from waiting onto active, like in the first walkthrough. Set hired to 1. At index 1 the value is still 1, so we need one more decrement at this column. The hired query ends at index 0, so after the sweep moves past 0 it no longer covers column 1. Waiting is empty, so nothing else can supply that decrement. The problem says to return -1 when zeroing is impossible even with all queries. Let n be the length of nums and qn be the number of interval queries. We sort the queries once, then sweep each index from left to right. Time is O of qn log qn for sorting, plus order n plus qn heap pushes and pops, each in log qn time, so overall O of n plus qn log qn in the worst case. Space is O of qn for the two heaps and the sorted copy of the query list, only a constant number of extra counters beyond that. Greedy left-to-right sweep, queries sorted by L, a max heap by R holds candidates, a min heap by R holds active intervals, hire until column I has enough coverage or fail. Function max removals takes nums and queries. Let n be the length of nums and qn the number of queries. Sort all queries by left endpoint L, breaking ties by original order. Waiting is a max heap of intervals ordered by right endpoint R. Active is a minute heap of pairs or comma L ordered by R. Set hired to 0 and pointer p to 0. For each index I from 0 through n-1. While the next query opens at column I. Push that query onto waiting and advance p by 1. While active is not empty and the smallest active R is less than I. Pop from active because that interval no longer covers I. While the number of active intervals is less than nums at I. If waiting is empty or the best waiting R is still less than I. Return -1 since we cannot cover this column. Otherwise pop the best interval from waiting and push its RL pair onto active. Increment hired by 1. Return qn minus hired, the maximum queries you can delete.